Evaluate each of the following limits. So we have the limit as x tends to 0 of sine x over x. Sine of 0 divided by 0 is 0 over 0. So this is an appropriate situation to use L'Hopital. So the limit as x tends to 0 of sine x over x by L'Hopital will be equal to the limit as x tends to 0 of cos x over 1. Cos of 0 is 1, so this is 1 over 1, which is 1. So the limit of the original should be 1. And this is one you should know because we actually use this in showing the differential of sine x from first principles. So let's look at the next one. So if we tend x to 1 here, 5 take away 4 take away 1 is the top, 10 take away 1 take away 9 is the bottom, so that's 0 over 0. So we have an indeterminate form. The limit as x tends to 1 of 5x to the 4 minus 4x squared take away 1 over 10 take away x take away 9x cubed is going to be the limit as x tends to 1 of 20x cubed take away 8x, the 1 disappears, and then we've got negative 1 take away 27x squared, which is 20 take away 8 over negative 1 take 27, which gives us 12 over negative 28, which simplifies to negative 3/7. Then we have the limit of e to the x over x squared, x tends to infinity. Well, that gives us, we have e to the infinity over infinity squared. That's infinity over infinity. And I realize you shouldn't use infinity in that way, but you get the gist of what we're doing here. And that's an indeterminate form. So the limit as x tends to infinity of e to the x over x squared is going to be the limit as x tends to infinity of e to the x over 2x. Now that will give us infinity over infinity again if we substitute, so we can differentiate again. So it's the limit as x tends to infinity of e to the x over 2, and that is going to be infinity because we will get e to the infinity on top, but we've just got 2 on the bottom, so we can now determine that it is going to go to infinity. And then the final one here is the limit as x tends to 0 from above of x log x. At the moment, we can't actually do this using L'Hopital because it's a product. And L'Hopital works for f of x over g of x. But we can rewrite this as the limit as x tends to 0 from above of ln x over 1 over x. And then we do have a rational function. If you stick 0 into this, what do you get? You're going to get ln 0 over 1 over 0, which is negative infinity over infinity. So it's indeterminate, and we can use L'Hopital. So the limit as x tends to 0 from above of ln x over 1 over x would be the limit as x tends to 0 from above of 1 over x over negative 1 over x squared. So that's 1 over x times negative x squared, which is negative x. So it's the limit as x tends to 0 from above of negative x, and that is just going to be 0.